Welcome back. So, um, mechanical weathering, something's physically breaking down the rock. Chemical weathering, a little bit different. In chemical weathering, it's the breakdown of rocks and minerals by chemical and biochemical reactions. All right. The chemical composition of the rock is changed, very much so. Types of chemical weathering include oxidation, hydrolysis, and solution chemical weathering. So, the first one, oxidation. That's just the science fancy name for rust, okay? This is the breakdown of rock by oxygen and water. All right? So what happens? Some rocks have a high iron content. And it's not the water itself hitting it to knock something off, but it's the water settling on it, reacting with the iron to create iron oxide, in this case, which is known as rust. That's an oxidation process. Typically, in an oxidation chemical weathering process, the rock changes color somehow. You can see that this rock, it looks like this part either was buried underground or had some other rock kind of sitting on top of it right on that section. So it was not exposed to the atmosphere and rain and such. But this was exposed, and if it got rained on and rain kind of pooled on it over time, it could cause it to rust. Rocks that contain, for example, the minerals pyroxene, amphibole, magnetite, pyrite, and olivine are most susceptible to oxidation because they all have high iron content. So iron, when mixed with air and water, oxidizes, rusts. So a lot of rocks contain these minerals, hence a lot of rocks, if exposed over time to a lot of water, will kind of change color, and it's typically an oxidation process. As they're changing color, that's undergoing a chemical change, pieces of it start to dissolve off. Think about a car. We don't have it too much here in Arizona, or at least in Phoenix, but when cars rust, that rust breaks down the steel, which has high iron content, and that steel flakes off, it breaks off, it weathers. And so that breaking down of steel to rust is an oxidation process. Same thing here. Not only is it changing the color, it's chemically altering the rock from what it was to something new, and pieces start to flake off. So that's oxidation. Hydrolysis. So this is actually a picture of the Dells up at, not Lynx Lake. The name escapes me, but it's a lake up in Prescott. And they form kind of a lot of these weird, round, pillowy kind of formations. And that's all a breakdown, a chemical weathering process due to something called hydrolysis. It's the breakdown of rock and minerals due to chemical reaction caused by water. Water changes. Hold on one second. Sorry. I had a phone call come in. But anyway, so hydrolysis. So hydrolysis is a little bit different than oxidation. So in oxidation, it's the combination of water and air to aid in breaking down rocks. In this one, it's basically just due to water. So in hydrolysis, it's again the breakdown of rock and mineral content due to a chemical reaction caused just by water. Some things can, over time, react just to water. You know, the most inert, benign substance on Earth, sometimes over long periods of time, geologic time, millions of years, things can react to water. So what happens is water changes the chemical composition and size of the minerals in the rocks themselves, making them less resistant to weathering. So they can't, they're more susceptible to weathering. And a rock that typically does this, which you kind of see here, is granite. Granite is commonly susceptible to hydrolysis. So it's changing the chemical composition and the size of the minerals in the rock. And because the minerals are changing a little bit, their ability to adhere together and the size helps them to break down. And you can get these kind of weird, rounded look to rocks, because this is, again, granite. Granite is typically a very tough igneous rock, very hard, but just water over time can cause this to occur. And then you have solution weathering. It's a removal of rock in solution by acidic rainwater. So all these are somehow tied to water, because again, it's the interaction of the sun and the water cycle and weather. But with solution weathering, it's the removal of rock in solution by acidic rainwater. It's not the actual water part, it's that it's turned slightly acidic. And so what happens, carbon dioxide is emitted when you're burning fossil fuels. So carbon dioxide, as it goes into the atmosphere, the more it collects in the atmosphere, it will dissolve into rainwater and turn that rainwater slightly acidic into carbonic acid. So the mixture of CO2 and water can turn the water slightly acidic into a slightly carbonic acid. And there are certain rocks, when you drop even very, very, very weak acid on something, it will cause it to break down and change chemically. Limestone is commonly susceptible to solution weathering. And limestone is also the rock that is metamorphosed, changed, we'll talk about that next unit, into marble. Both limestone and marble are very common building materials. They're very common in use of creating statues and or gravestones. So when you see, for instance, I'm assuming this is George Washington, that looks like this, the sculptor didn't make it look like that. Over time, over 100 or so years, as we pumped more CO2 in the atmosphere, turning some of the rainwater slightly acidic. It's not like acid rain, a movie where it falls on your skin and your skin starts bubbling. You don't even notice it. It's just slightly acidic. But rocks that are susceptible to that, like limestone or marble, they very much do. So even a little bit over time will start to break down these rocks, and again, statues and gravestones and some building materials commonly made of limestone and marble. It can also create caves below the surface. So if you have a layer of limestone rock, which is a sedimentary rock, so more on that in a little bit. If you have a layer of limestone, and if you have acidic rain percolating down through the soil and reaches this layer of limestone rock, it will also eat away the rock underground, forming vast cave systems and a type of topography called karst. More on that later. So there are some factors that are affecting weathering. The most important factors that affect weathering, how fast it occurs, the type that occurs, etc. So surface area. So how much of the rock is exposed? Right? If only a little bit is exposed, only a little bit will weather and break down. The more that's exposed, the more it can break down. It takes time. So how long has this weathering process been eating away at this rock? The type of rock, the composition of the rock itself. Different rocks have different chemical makeups and more or less susceptible to different types of weathering, whether it's mechanical or chemical. Climate plays a big part. Temperature and rainfall, because it's really the climate, the weather, that really aids in breaking down these rocks, and the type of weathering, mechanical or chemical. Of all of those, climate is definitely the main factor in weathering. Climate affects weathering in two kind of primary ways. Chemical weathering is much more prevalent in warm, wet tropical climates, and it usually occurs very quickly and extends to great depths even. So chemical weathering, so the breakdown of rocks, more prevalent in warm and wet tropical climates, whereas mechanical weathering is actually more prevalent in cold, dry regions. And so if you think about Phoenix, well, we're neither of those. We're warm, so maybe chemical, but we're not wet. We're dry. So we're warm and dry. So we're not chemical and we're not mechanical. So what kind of weathering occurs, for example, in the Phoenix area? None, really. That's why a lot of the rocks around here, a lot of the mountain peaks around here are very, very sharp. There's not a lot of weathering that goes on. We can use this chart to help us figure that out. For example, so this side of the chart is mean annual temperature, and it's in degrees Celsius. But hotter locations would be down here, warm or colder locations up here. On the bottom x-axis scale, we have annual rainfall, and it's measured in centimeters. But if a climate is dry, less rainfall. If a climate is wet, more rainfall. So Phoenix area, so the average mean temperature, obviously very hot, and then also very dry. So that puts us right in this realm here. So for instance, Phoenix, there's very slight weathering that occurs, and if it does, it's mainly by wind. Sometimes wind will carry small pieces of sediment and will act kind of like as an abrasive. But for the most part, again, you look around here, a lot of the peaks that surround us are still very sharp and jagged. Weathering doesn't happen here. We don't usually. Okay. But what about, again, looking at locations that are cold, moderate mechanical, 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 mechanical. So cold, again, cold and dry, mechanical, kind of warm and wet, chemical. And then places like us in the desert where it's hot and dry, we don't really get weathering. Kind of interesting to think about. Before I go, let me give you part of the super secret code. It is the number 0. One more time, the number 0. Again, the number 0. So let's pause here. When we come back, we'll tiptoe into section 2 on sediments. So we've broken down material, broken down existing rocks via weathering, mechanical or chemical. Now those broken down pieces are known as sediments, and we'll get into that next section. I'll see you back here in just a second.